So on this question, it says you're interested in investigating whether the same proportions of men and women at your college are math science majors. A survey of 500 men at the college resulted in 15% math science majors. A survey of 300 women at the college resulted in 20% math science majors. What can be concluded at the alpha 0.10 significance level? So first question, what is the correct statistical test to use? Well, you can see right there it's homogeneity. But I wonder if you'd really be able to figure it out if the answer wasn't sitting in front of us. Let's go look at the notes. This is part of the big trick. How do we know this is homogeneity? Well, here's homogeneity. Notice it says test to see if two different samples have the same distribution. That's us because we have the men and the women, and we're surveyed the men, what percent are math science, and surveyed the women, two different samples. See up here for goodness of fit, it says tests only one sample. And for test for independence, it says tests only one sample. So that's the key. There's two samples. Now you might be confused, go, oh, well, there's category percentages. It's got to be goodness of fit because there's category percentages, but no, it's not. Even though, yes, there are percentages, goodness of fit is for only one sample. Homogeneity is two, meaning homo means same. You're seeing if two different samples are really the same. Two samples. Only two, one sample for independence, one sample for goodness of fit, two samples for homogeneity. See back here how it says there's two samples. A survey, I'm underlining, a survey of 500 men, that's the first sample. Then over here, a survey of 500, 300 women. Second sample. So we have two different surveys or samples. So this is a test for homogeneity. All right, so don't be fooled by that. All right, let's go on. So now that we know it's homogeneity, what's our HO? HO says the two variables have the same distribution. H1 is different, same, different, same, different. Okay, so same, same for each gender, and not the same or different for each gender. There we go. All right. Test, statistic, and p-value. Well, for those, we go to the calculator. Now, what calculator are we going to go to? Well, again, we're at test for homogeneity. So the online calculator is test for homogeneity. What a surprise. All right. So let's go. Test for homogeneity is number 23. See it down there? 23. Test for homogeneity. All right. When you click on it, you get these two columns, A and B, and you have to put in the numbers. So that's a little tricky on this one. Come back to the question. You're like, well, how do I know what numbers to put in? See, they didn't give them to us in a table. They didn't even list them out. So we're going to have to do like this. We're going to have to go like men. And then over here, I'll do women. Got men and women. So, and what are the categories? Well, they can be math science majors or not math science majors, right? That's what we're talking about. We're talking about men, and 50% were math science majors, so the rest were not. So what does that mean? So that's 15% of the 500 men. Remember, there's 500 men. So if you multiply that in your calculator, 0.15 of is always times 500. What are you going to get? 75. 75 men out of the 500 were math science majors. Well, then how many were not math science? Well, the rest. So how are we going to figure that out? We'll subtract from 500 because remember, there's 500 men altogether. That leaves 425 that were not math science. And then over here, how many women were math science? Well, it says 300 women, 20% were math science. That's 20% of the 300 women were math science. So that's 0.20 of is always times 300, which equals, what's that? 60. 60 of the women are math science. And how many are not math science? Well, subtract because there's 300 women altogether. There was what, 500 men altogether. So subtract from 300, 300 take away 60, because if 60 are math science, the rest are not. That equals 240. So we're going to do a chart then that says men, women, and we're going to do math, science, and I'll go not math, science, and we're going to go. The numbers we're going to put in this chart are 75, 425, 60, and 240. Is that making sense? See how I came up with that? We had to kind of make our own chart this time because they just gave us percentages, but we've been doing percentages all semester. You know how to do those, right? So again, it said 500 men surveyed, 15% are math science. So 15% of the 500, 0.15 times 575 of the men, are math science. The rest are not. So subtract from 500, 425 are not. Same thing for the women, 20% of the 300 women surveyed are math science. Multiply that in your calculator, 0.20 times 300. Get 60 of the women are math science. The rest are not. So subtract from 300. Total women, 240 are not. There's our four numbers. Those are the four numbers that we're now going to go to the homogeneity calculator and put in. So again, we had to make our own table. We had to recognize we're talking about men and women being a math science, men and women and math science major or not math science major. So here we go. That's the hard part probably. To the calculator. So 75, 425, 60, and 240. There we go. And then just hit calculate. So just put those numbers in there, hit calculate, right? Just put those four numbers in there, hit calculate. The p-value is 0.0675. There's the chi-square number 3.3416 or 17. Let's go back. Yep, there they are. There's the p-value. Here's the chi-square number. It looks like an x square, but it's a chi-square from Greek. There they are. This is the p-value, what we really care about. So, all right, let's wrap this thing up. So p-value is 0.0675. How's that compared to the alpha? What was the alpha? Right there, 0.10. 0.10, that's pretty easy. The p-value is less, isn't it? 6 is less than 10, right? If you're not sure, line them up. 0.10, whoops, 0.0675. You see what I mean? I mean, line up decimal right over decimal, and then fill in zeros where you have gaps, blanks. You can see 1,000 is bigger than 675, right? So the 10% is bigger, 10% is on the wide side. All right, so then what's our statement we always say? If the P is low, then the HO, the null, must go, meaning go away, right? If the P is low, the null must go. Is our P-value low? Yeah, our P-value is less. It is indeed low. So that means in our case, the null HO, we're going to reject it, aren't we? The null must go away, reject HO. That's what we say right here, reject the null. And so then if we're rejecting the null, that must mean we're keeping the other one. So we're keeping H1, aren't we? So if you reject the null, you keep the other one, you keep H1. So then we're going to go back up and do whatever H1 says. Now remember, HO is always, in every hypothesis test, weak evidence. And H1 is always, in every hypothesis test, strong evidence. So every time, right? So we say, okay, we're keeping HO. Keeping H1. H1's our baby. Let's go up here and get our hands on H1. That's the one we're keeping. It's this one. That one. Okay, so we're keeping H1, which says what? Strong evidence and different or not the same, whatever. So we're saying there's strong evidence that those groups are different, right? That the number of men and women that are math science majors is different. There's strong evidence that they're different. Come on down. Okay, now strong, yes, I'll write it here. Strong evidence that they're not the same, that they're different, however you want to say that. So, okay, sufficient? No, no, no. That was quick. I rid of three of those, right? Because it's strong. Strong. Oh, wait, wait. I mean, those are, what am I doing? Those are what we want, huh? All right. So strong does mean sufficient. Strong. Strong is sufficient. Get rid of the insufficient ones. There we go. Yeah, we want sufficient. If something is strong evidence, it's sufficient. It's enough evidence, huh? It's enough evidence to prove that they're not the same or they're different. Sufficient evidence to prove they're independent? No. Sufficient evidence to conclude that they're not the same. There we go. What was the other one? Sufficient evidence is the same? No, no, no. This one. So there's sufficient evidence to conclude that college major, the distribution of college major is not the same for each gender. Men and women, it's different. It's different. How do we conclude that again? Well, it's our saying. If the P is low, then null must go. Our P-value was low. 6 was less than 10. So the P is low, then null must go. So reject the null, which means you're keeping the other one, keeping H1. Up here, H1 said strong evidence, different or not the same. So we said sufficient evidence, not the same. And so there we go. But the main trick was making that table up there. So that's how we do it.